Hello everyone, so welcome to the YouTube channel of YourPedia here. I am Vinay Sharma, your mentor of mechanical engineering. So as you know, the CSL has conducted the exam on 27th of April here. Okay now, so in today's videos I am going to do the solution of that particular exam, and along with that I will tell you that in which question you can raise the objections here. Okay, and as you know, the exam has taken place now. Now the next stage is the writing skill there. Then we are going to have see the GT, and then we have an interview. Okay, so last three stages has been left now after this particular exam here. Okay, now if we talk about the group task here, in this case the GD is not taking GD is not there, but you have to go for the GT task. Okay, group task, and the group task is a little bit different from the HPCL, all the other PSU which take the GTs here, and the YourPedia team is going to help you with that also. Okay, so if you are well ensured that you are going to clear this particular exam here, then you can join us for the preparation for the writing skills as well as the GT as well as the interview here. Okay, now let us see the solutions of this particular exam here. So here we have first question, you can see. So I have taken the exact question paper here. So in the first question you can see the specific speed of a turbine is defined as the speed of geometrical similar turbine producing the maximum efficiency, maximum discharge as well as the unit power under the unit head, minimum losses here. So that is a very simple question. Okay, this is a question related to the simple definition of a specific speed, and we know when we talk about a specific speed of a turbine, okay, it is defined on the basis of the unit power produced under the unit head. So option number 3 is the correct answer here. Okay, so there is no need to mark the objection. Coming back to the next question, Taylor tool life equation where V is a cutting speed, T is a tool life, N is a tool life exponent, and C is a constant for a particular tool work combination is. What is the expression of Taylor tool life equation is? That is also a very simple question. Here we already know that the expression is simply written as VT and to the VT and equal to constant here. Okay, now so option number 4 is also a correct answer here. Okay, there is no need to mark. Next, coming back to the next part. Water flows in a pipe reducing from a 0.2 meter to 0.1 dia. If the velocity in the larger pipe is 2 meter per second, what will be the velocity in the smaller pipe? So if you just see here, if we talk about the pipe, if we take a case of a pipe here, okay, now at a cross section number 1 we have a diameter of 0.2 meter. 0.2 meter. At a cross section number 2 you are going to see the diameter as 0.1 meter here. Okay, and correspondingly the velocity in the larger pipe is given to us 2 meter per second here. So in this case you can simply write down the continuity equation. So if you use that expression, you can write A1 V1 is going to be equivalent to A2 V2. So we want to calculate the value of the V2 here in this case. So if you just see, if I calculate the value of the V2, it will come out to be as A1 V1 divided by A2. Understood? Now what will be the value of the areas here? So area can be simply written as pi by 4 d1 square V1 divided by pi by 4 d2 square into V2 into pi by 4 d2 square. That will be the expression here. Okay, so if you just simplify it, you are going to get V2 is coming out to be. Now what is the value of d1 here? d1 is 0.2 meter, velocity is given to us 2 meter. So I can write 0.2 square multiplied by 2 divided by 0.1 square. So if I just solve this entire equation, you are going to get the answer as 8 meter per second here. Okay, now so option number C is also a correct answer here. Coming back to the next question. Two springs are in parallel. The overall stiffness of the two spring would be equal to. Now just see, the question can be asked here from the parallel combination as well as for the series combination. So if we talk about a parallel combination, in this case, we already know that the equivalent stiffness is having a simple formula that you have to add sum up all the resistances here. So if the value of the stiffnesses are same, okay, in that case I can write K1 plus K1, it is equal to 2K1. Okay, so equivalent stiffness is going to be twice of the stiffness here. So answer will be the 2K here. So option number 4 is the correct answer here. Coming back to the next part. Steel with ultimate strength 600 megapascal has an approximate endurance limit here. Okay, now just see, in this case we have a standard formula. We can calculate the value of endurance strength of a steel by using this particular formula. So the relationship between the endurance strength and the ultimate strength is written as SC is equal to 0.5 multiplied by SUT. So if I just put the value of the SUT as 600 megapascal, SE will become 300 megapascal there. Okay. Now I can write the option number 4 is the correct answer here. Okay, so there is no need of objection here. Next part, divergence of a vector field represents it. So that is a very simple question again. Okay, if we talk about a divergence, curl and vector here, so here the divergence of a vector field represents the flux density here. Okay. Next part, the Laplace transformation of exponential to the power minus 2 into t here. So what is the formula of the Laplace transformation here? So if you just take the Laplace of exponential to the power minus a into t, it is having a formula of 1 upon s plus a. So here I can say if you replace the a with 2, you are going to get the value of the Laplace transform as 1 upon s plus 2 here. Okay, now so I can write option number 3 is going to be the correct answer. Okay, so option number 3 is the correct answer. That's again a very simple part. Next part, a bolt is subjected to an initial preload of 30 kilonewton with an external load of 10 kilonewton. So here the external load of 10 kilonewton is acting over the bolt, and correspondingly the stiffness ratio or the stiffness factor is given to us. The stiffness ratio value is given to us as 0.3. Okay. Now in this case, if you just see, we have to calculate the what will be the resultant force in the bolt. So whenever you are tightening the bolt here, there is some external, there is some initial preload has been provided into this, due to which the resultant force which is acting over the bolt is much more than the force which is acting over the bolt here. So it is having a formula of P equal to Pi initial preload plus multiply by stiffness ratio multiply by the, I can write, external load. Okay, so if we just put all the values into this expression, I can write 30 plus 0.3 multiply by 10. So final answer will come out to be as 33 kilonewton. Okay, now so in this case option number A is going to be the correct answer here. Okay, so here you can raise an objection here. Okay, and if you want to get a source here, you can just mark the source from the VV Bhandari. Okay, or you can mark the source from the RS Kurmi also by machine design. Okay, machine design by RS Kurmi or machine design by VV Bhandari there. Okay, so there you can see the simple formula or relating to the stiffness ratio, initial preload and the external load also. Now coming back to the next part, a Carnot cycle operates between the two temperature T1 and T2 if T1 is increased by delta T and T2 is decreased by delta T here. Then the efficiency neta 2 in the second case and the efficiency neta 1 in the first case are related by. So here you can see, if we talk about the Carnot cycle, the Carnot cycle efficiency can be written as 1 minus TL by TH here. Okay, so if you write in the form of T1 and T2, you can see lower temperature is T2. Lower temperature is T2. Now what we are doing? So basically, if you just see, we are decreasing the T2 by delta T and we are increasing the T1 by delta T here. So I can write, I am reducing the lower temperature and I am increasing the higher temperature there. Okay, so correspondingly, if you just see, the negative term is getting increased, so correspondingly the efficiency is also going to be increased here. So due to the decrease in negative term, the efficiency is getting increased here. So I can write option number 2 is the correct answer here. Neta 1 is going to be less than the neta 2 here. Okay, now next part, the velocity profile for a fully developed laminar flow. That is a very simple question. We know in the case of a laminar flow, we have a parabolic velocity distribution. If we talk about a turbulent flow, we are having a logarithmic distribution here. So option number B is option number 2 is a correct answer here. Next part, in a multi-stage compression as compared to the single stage compression, the volumetric efficiency is going to be. First of all, what is the meaning of volumetric efficiency here? Volumetric efficiency is having a formula of 1 plus C minus C PH upon PL. So here you can see, if we are having a single stage compression here, okay, so in the case of single stage compression, let us suppose if the initial pressure is 1 and the higher pressure is, let us say, 8. So you can see the pressure ratio is going to be about 8 here. But if you opt for the multi-stage compression, in that case the pressure ratio is going to be less here. Okay, and why do we prefer use the multi-stage compression, because the work input into the compressor will get reduced. Correspondingly, due to the decrease in the pressure ratio, the corresponding volumetric efficiency also get increased here. Okay now, so I can write the option number A is the correct answer here. Next part, an ideal gas at 27 degrees Celsius is heated at a constant pressure till the volume becomes 3 times the temperature of the gas will be. Okay, so here the ideal gas is performing a constant pressure process, and in this case we know that volume is directly proportional to temperature. So I can write T2 by T1 is equal to V2 by V1. Okay, so here you can see initial temperature is 300 Kelvin. Final volume is 3 times of initial volume divided by V1. So correspondingly, if I just calculate the value, it is coming out to be 900 Kelvin there. Okay, it is coming out to be 900 Kelvin. 900 Kelvin is equivalent to 627 degree Celsius here. Okay, so option number 2 is the correct answer here. Next part, which law of thermodynamics forms the basis of a temperature measurement? That is a very simple question. Zeroth law of thermodynamics forms the basis of a temperature measurement because it provides you the concept of thermal equilibrium. And for measuring the temperature here, we require a thermal equilibrium to be established between the two different entities here. Okay, now coming back to the next part. In a keyless propeller fit, the insufficient hydraulic push-ups lead to. Now just see the question carefully. If you don't have an idea that what is it talking about, just see the wording from the question, you can mark the correct answer. Here we in the case of a keyless propeller fit, okay, insufficient hydraulic push-ups. So hydraulic push-ups, we are having an insufficient push-up here. Okay, we are providing insufficient force to create a fit here. So in that case, what we're going to have? We are going to have reduced interference and loss of frictional torque transmission here. So you can see option number A is the correct answer here. Remaining all the options are the wrong one only. Okay, now you are not going to have an improved alignment. You are not going to see the effect in shaft diameter. Okay, excessive hoop stress is here. So option number 1 will be the correct answer here. Next part. A rotor with I equal to 50 kg meter square rotates at 3000 rpm and precedes at 1 radian per second. Gyroscopic couple is. What is the formula of gyroscopic couple? Gyroscopic couple is given by I is equal to omega into, C is equal to I into omega P. So here you can see gyroscopic couple C will be equal to 50 kg per meter square. What will be omega? 2 pi 3000 divided by 60 multiply by 1 here. Okay, so if you just calculate it, you are going to get the gyroscopic couple here. So questions are very simple. Here the answer will come out to be around 15707 something here. Okay, this type of answer you are going to get. So option number B is going to be the correct answer. Next, when balanced weights are introduced in a plane parallel to the plane of rotation of the disturbing weight. So let us suppose if you are having a shaft like this one and here you are having a disturbing weight. Okay, now you want to balance the weight here. Now what you have done, you have just placed a balanced mass in some other plane. Okay, so balanced mass is placed in a plane parallel to the plane of rotation of a unbalanced mass. Then the minimum number of balanced weight for balancing a single revolving distributing weight will be 2 here. That is the correct one. Why? Because let us say if it is 2 kg and if you have placed the mass of 2 kg here, then the forces are going to be balanced, but the unbalanced moment will be there. So in order to maintain the, in order to balance the couple or a moment, what we have to do? We have to make ensure some other mass is also placed here. Okay now. So in this case, 2 masses are required to do a complete balancing here. In the case of dynamic balancing here, you have to balance the forces as well as you have to balance the moment also. Next part. A household refrigerator removes 150 kJ per minute of heat from its food compartment. The compressor consumes 2 kW of electric power. Calculate the coefficient of performance of the refrigerator. What is the formula of the COP of the refrigerator here? COP of the refrigerator is given as desired effect upon work input. So here you can see desired effect is given to us 150 kJ per minute and work input is 2 kW here. Okay. So if I just solve it, you are going to get the COP will come out to be around 150 divided by 120. If I further do the calculation, the answer will come out to be as 1.25. Okay, so option number C will be the correct answer here. Next, what will be the crystal structure of alpha iron? That is a very simple question. BCC is the crystal structure of alpha iron here. Okay, if we talk about a gamma iron, we have a FCC structure. If we talk about a delta iron, again we are having a BCC structure there. Next, a fluid flows through a pipe of diameter d with a velocity v. If a diameter is reduced to d by 2, the flow will remains incompressible. Then what will be the new velocity? You have to calculate here. So again, you can see, you can apply the continuity equation. Okay, you can apply the continuity equation in this way. So here in this case, a1 is given to us pi by 4 d square, velocity is v, a2 is pi by 4 d by 2 whole of square, v2 you have to calculate. Okay, so if you just solve it, you are going to get the final answer will come out to be as 4 times v here. Okay, now, so I can say option number B or option number 2 is a correct answer here. Next, for a Newtonian fluid, the rate of shear stress is proportional to the shear strain. Rate of shear stress is proportional to the rate of shear strain. Shear stress is proportional to shear strain. Shear stress is proportional to the rate of shear strain. So option number D is a correct answer here. For a Newtonian fluid, we know that tau is directly proportional to the velocity gradient du by dy, or I can write tau is directly proportional to the rate of angular deformation here. Okay, now, so I can say the shear stress is proportional to the rate of shear strain. But if we talk about a solid body, in that case the shear stress is directly proportional to the shear strain for a solid body. Okay, just remember that part. Next, if a company has an annual demand of 10,000 unit and ordering cost of $50 per order and a holding cost of $2 per unit per year, what is the EOQ? What is the formula of EOQ here? EOQ is having a simple formula as T2D C0 by CH. That is a formula here. So just put all the values into this expression and get your final answer. So here you can see CO is given to you 50, holding cost is $2 per unit per year. So if you just calculate it, you are going to get 707 something here. Okay, so that is a value of the EOQ. Okay, so option number 1 is going to be the correct answer in this case. Now in this question, here you can see in a gas tungsten arc welding process, the following parameters are used. Arc voltage is 24 volt, welding current is 180 ampere and the desired heat input is 0.5 kilojoule per millimeter. However, due to the machine limitation, the travel speed must be set in centimeter per minute here. What is the recommended operating speed to achieve the desired heat input? So here you can see, first of all, in this case the desired heat input is given in the form of kilojoule per millimeter, but you have to calculate the answer in centimeter per, I can say millimeter, centimeter per minute here. Okay, the question is very simple. You have to just put all the values in the direct expression here. Okay, now what is the expression here? So here we have an expression here. You can write the operating speed can simply be written as V into I upon the desired heat input here. So in this case, the arc voltage is given to us 24 ampere. Sorry, 24 voltage here. I is given to us 180 ampere. Okay, and what is the value of the desired heat input? Heat input is given in kilojoule per millimeter. I am writing it in the form of joule per millimeter here. So it will be 500 joule per millimeter. 500 joule per millimeter. Okay, so if you just solve it, you are going to get the final answer in the millimeter per second here. So this is representing the desired speed here. So its value is coming out to be around 8.64 millimeter per second here. Okay, now you want to convert this value, you have to convert this value in the centimeter per minute here. So just do the conversion. So you are going to get 0.864 centimeter multiply by 60. Okay, and the final answer will come out to be in the form of centimeter per minute. Okay, so option number A is going to be the correct answer in this case. The question is very simple. Now coming back to the next part, maximum efficiency of the engine between the 800 Kelvin and 400 Kelvin will be. So here maximum efficiency we have to calculate, so that means we have to calculate the Carnot efficiency. Okay, it is having a formula of 1 minus 400 divided by 800. So if you just solve it, you are going to get the answer as 50%. Okay, so option number 1 is going to be the correct answer here. Next part, for a reversible adiabatic process, which of the following thermodynamic relation is correct here? If a process is reversible, that simply means the change in entropy is going to be 0. If the process is adiabatic, we can simply say the heat transfer is going to be 0. So in this case, we know that in the case of reversible adiabatic process, which is an isentropic process, change in entropy is going to be 0. So dq is equal to 0 and the ds will be 0 there. Next, a two-stroke engine has a speed of 750 rpm. A four-stroke engine having an identical cylinder size run at 1500 rpm. the theoretical output of the two-stroke engine will be the same as that of four-stroke engine, 3/4 that of the four-stroke engine, half that of four-stroke engine, twice that of four-stroke engine. First of all, if we talk about the theoretical output here, theoretical output is given by brake mean effective pressure multiplied by area multiplied by length multiplied by speed here divided by K divided by 60 there. Okay, so this is a formula. Mean effective pressure multiplied by area multiplied by length of stroke multiplied by the effective speed multiplied by the number of cylinder divided by 60. Okay, so the answer will come out to be in kilowatt. But now you have to remember that this N is representing the effective speed. So as we know, in the two-stroke engine we are having a power stroke in each revolution. So I can write N is going to be equal to capital N in the case of two-stroke engine here, and the corresponding N is small n is going to be equivalent to half of the speed of the engine here in the case of four-stroke engine. Why? Because in the case of four-stroke engine, every 2 revolution is going to give you 1 power stroke here. Okay, now so here if you can see, here I am assuming mean effective pressure is same, area is same, length of stroke is same, number of cylinder is also same. Okay, so correspondingly if you write for the two-stroke engine, the formula will be written as PMAL 750 multiplied by K divided by 60. And if you talk about a four-stroke engine, you are going to get mean effective pressure area into length of stroke multiplied by 1500 divided by 2 multiplied by K divided by 60 there. Okay, so theoretically they are providing you the same values here. So I can say both of these engines are going to give you the same theoretical power output. Okay, now so option number A is going to be the correct answer in this case. Next, log mean temperature difference is used in the case of. So this is a very simple question. It is basically used in the case of heat exchangers here. So option number C is going to be the correct answer. Next, what is the meaning of effectiveness of a heat exchanger? Effectiveness of a heat exchanger is simply defined as the ratio of the actual heat transfer to the maximum possible heat transfer which can take place in a heat exchanger here. Okay, now so option number 2 is the correct answer here. There is no need to mark the objection in any question right now. Next, in casting, what is the use of riser? Riser is provided to, so that is a very simple question. In that case, it is being provided to compensate the shrinkage here. Okay, and if we talk about a shrinkage, there can be liquid shrinkage, solid shrinkage, as well as the solidification shrinkage here. Next, the Biot number represents the ratio. What is the meaning of Biot number? So Biot number is defined as simply the internal conduction resistance to the external convection resistance here. Okay, so in this case you already know it is having a formula of HL by K. So if the Biot number value is Biot number value is less than 0.1, we are having a lumped body analysis here. Okay, what is the meaning of lumped body analysis? That the conduction resistance is very negligible, so that the body is having a uniform temperature throughout its cross sections here. Okay, now Nusselt number represents you. What is the meaning of Nusselt number? Nusselt number is basically defined as the ratio of the convection heat transfer which is taking place through a fluid layer corresponding to the conduction heat which can take place when the fluid particles are stagnant here. Okay, and the value of the Nusselt number is always going to be more than 1. So you can see again the option number 2 is the correct answer here. Okay, now next part, what does the eigenvalues of a system determine? Pressure, velocity, density. There is no need to read this question entirely here because option number 4 is the correct answer only. Okay, now next part, if the angle of friction is 0, then what will happen? What is the meaning of angle of friction? So as we know that the coefficient of friction is basically equivalent to tan of theta, where theta is representing the angle of friction there. And if you just see, mu is equal to friction force divided by normal reaction. Now in this case, if the value of the theta is equal to 0, then I can write F is equal to 0 also. Okay, the force of friction will again become equal to 0. So option number C is a correct answer here. Next, a hydraulic turbine developed the 3000 kilowatt of power under a head of 60 meter. If the head is reduced to 30 meter, what will be the power developed here? So in this case, in the case of hydraulic turbines, we know that power is directly proportional to head to the power 3 by 2 here. So I can write P2 by P1 equal to H2 by H1 to the power 3 by 2 here. Okay, I can write the expression in this way. So now you can see initial power is 3000 kilowatt corresponding to a head of 60 meter. Okay, so in this case, if you just solve the problem, you are going to get the answer as how much answer you are going to get? Option number C. Okay, the P2 value will come out to be nearly about 1060 kilowatt. So just do the calculation and get your final answer here. Next, a thin walled pressure vessel is subjected to the internal pressure here. The ratio of the hoop stress to the longitudinal stress is given by. Now in this case, if you just see, the hoop stress is having a formula of PD by 2T here. If we have having a longitudinal stress, it is having a formula of PD upon 4T here. Okay, if you just take the ratio, so you are going to get the hoop stresses are double of the longitudinal stresses here. Okay, so option number D is the correct answer here. Next part, the stress concentration, choose the correct statement first. Now, stress concentration factor is independent of the geometry of the machine component. That is a completely wrong statement, because depending upon the geometry here, we are going to have a varying value of the stress concentration factor here. If the geometry is having a sharp corner, the stress concentration will be very, very high. If the geometry is having a I can say the large curvature values here, large curvature surfaces here, there is no, I can write, there is no corners here. In that case, stress concentration will be very, very less. Endurance limit of a material subjected to fatigue loading depends on the surface finish and the ultimate tensile strength of the material. That is a correct answer here, because if you just see, if you want to increase the endurance strength of a material, you have to make ensure the surfaces are not, should not be rough here. Okay, now, so I can say the surface finish is basically affecting the endurance strength of a material here, and it is also depending upon the ultimate tensile strength of the material, as we have seen in the starting questions here. Okay, there we have, where we have to calculate the endurance strength of a steel. Okay, now, so option number B is a correct statement here, so you don't have to read out the remaining options also. Next part, boundary layer thickness in a laminar floor, a laminar flat plate floor varies as. So what is the formula in this case? So we are having a formula as delta upon x is equal to 5 divided by under root of local Reynolds number. So if you just solve it, you are going to get delta is directly proportional to x to the power 1 by 2 here. Okay, now, so option number B is going to be the correct answer. Next, two forces of the magnitude 4 Newton and 5 Newton acts at an angle of 60 degree. The resultant force is equal to. Now just see, here we have two forces, one is 4 Newton, the other one is 5 Newton, and they are having an angle of 60 degree in between them. So if you want to calculate the value of the resultant force, you can use the parallelogram law of vector addition. Okay, so according to that, you can write down the expression as a square plus b square plus 2 ab cos of 60. Okay, so just solve it and get your final answer here. So here in this case, you are going to get the answer as 7.8 Newton. It is a correct answer here. Just put all the values and get your final answer there. Okay, now, next part, two pipe of uniform section but different diameters. Dhyan rakhna. So just take care of different diameters here. It carries the water at the same volumetric flow rate. So volumetric flow rate is same. So can I say that in that case, the pipe which is having a lower value of the lower diameter here, it is having a velocity much higher as compared to the second case. Okay, now water property are same in the two pipe. The Reynolds number based on the pipe diameter. First of all, the pipe which is having a smaller diameter, it is going to observe the high velocity. Okay, and larger the velocity of the fluid, the corresponding value of the Reynolds number is also going to be higher here. Okay, now, so I can say the Reynolds number is going to be higher in the smaller pipe, and the Reynolds number is going to be smaller in the large diameter pipe here. So I can write option number C is the correct answer. The Reynolds number is going to be large in the narrow pipe here. Okay, now, and it is going to be larger in the case of, just give me a second. Yeah, it is going to be smaller in the case of a narrow. Just give me a second. Reynolds number we have to calculate now. Yeah. So in the case of a, Reynolds number in the narrow pipe. Yeah. In the case of a narrow pipe, the diameter which is having the pipe which is having a smaller diameter, it is going to observe a high Reynolds number there. Okay, now, and in the case of narrower pipe, you are going to have a larger Reynolds number, not the smaller one. So option number 1 is a wrong one. Next part, thermal efficiency of a Carnot engine operating between the source temperature 727 and sink temperature 27 degrees Celsius here. So here you can calculate 1 minus 300 Kelvin divided by 1000 Kelvin. So if you just solve it, you are going to get the answer as 70% here. So option number 1 is going to be the correct answer. Next part, last question. In a cam follower system, the undercutting occurs when the follower diameter is very large, radius of curvature of a cam profile is small, cam speed is low, base cycle radius is too large. So in this case also, the option number 2 is the correct answer here. Okay, if the value of the radius of curvature is very small, in that case you are going to see the undercutting occurs here, due to which the failure can take place. Okay, so here in this exam paper you can only mark only one option as a objection here, that is question number 8, I think. Okay, now in which the question related to the bolt here. Okay, and now the exam has been conducted. Now the next stage is writing skill here. So just now focus on the writing skill, group task, as well as for your interviews here. Okay, now so now YourPedia has already been conducting all of these things here. So if you want to just practice related to the writing skill, group task, or the interviews here, you can connect with us. Okay, now we are going to help you with that particular thing. Okay, so thank you very much.